Good morning, students. Welcome to CMD lectures. Okay, in the last class, we discussed about the various things about the threaded forms and all these things. Okay, we will start with the today's session. Okay, so this in today's sessions in the previous class. In the previous class, we discussed all these things. So how to do internal threads, how to do external threads, and all these things, operations, how this is going to be done. Comparison of thread cutting, external thread cutting and internal thread cuttings. So measure dia, all these things, start from there. Okay, you can see here how it is being started. So step by step it is been. Here comes to internal thread. Okay, the minor dia it's been taken out. Okay, the crest is there. Okay, you can see over here. Okay, so hope you getting these things. So we are coming to, we ended up over here last class, detailed representation, how to represent the threads. Okay. So detailed representation is there, schematic representation is there, simplified representation is there. So we go with the simplified representations. Very, very important how to represent the threaded things. Okay. So you will be understanding in the industry level how the threads are being represented, whether it's an internal thread or external thread, what is the thread size, and all these things are need to be highlighted on the drawings. Okay, so you should know these things very clearly. Okay, detailed representations. Okay, so here using slanting lines to represent the crest and root. Okay, so we discussed already what is mean by crest, what we mean by root. Okay, so here you can see over here. Okay, external threads, slanting lines. Okay, so one is the, this one is showing with the top, okay, that is crest, and this one is, another one is showing with the, okay, you'll see here. So this one is for the crest, okay, and this for the root. Okay, so this is like this. Okay, so here also in this, okay, so this is the root side and this is the crest side. Okay, okay, you can see over here roots and crests are drawn in sharp. Okay, so you can see over here. Okay, so these are the shown with the sharp lines, crest and with the highlighted one. Okay, here also you can see this. Okay, both the side you can see. Okay, so this is showing the things detailed. Okay, so it is showing with the thread angle, thread angle, thread angle of third angle, angle of 60 degree, and it is showing the pitch. The distance between crest to crest or root to root, okay, consecutive root is called as pitch. Okay, it is showing all these things. So it is thread runout. Okay, so where it is going to start, where, okay, or where it is going to end in the this side. Okay, so all these things up to where it is going to stop. Okay, all these things. Okay, thread runout. Okay, runout means stops. Okay, thread stops, runout. Okay, up to here it's going to stops, up to here it is there threads. Okay, so next we can see the highlighted portion. What you are going to see is schematic representation. The schematic representation uses alternate long and short, uses alternate, you can see this word alternate, long and short, long and short lines. Okay, alternate long and short. Okay, long and short, okay, lines for representing the crest and roots of the thread respectively. Okay, so long lines will be representing the crest, long for crest, crest, and short for root. Okay, so all these things can be seen over here. So here it is showing. Okay, so it is a pitch over there. Okay, so pitch is there and all these things. Okay, so root is being shown over here. Okay, so thick lines. Okay, thick lines for the root and thin lines for the crest. Okay, so this is very important for representing the things. Okay, so thick means root. Okay, root should be very thick and crest should be thin. Okay, thin, it should be representative. Okay, so similarly for here also. Okay, so the coming to internal thread, so it is giving like this. Okay, so long lines for crest and short lines for a root. Okay, okay, simplified representations. Simplified representation. Okay, earlier it was schematic. We discussed about the detailed, schematic, and simplified. Okay, now we are going with the simplified representations. Okay, so how it is being simplified? Okay, okay. So what it says, you can see over here. Okay, so simplified use of thick and thin lines, thick continuous lines. Okay, so understand this. Okay, thick continuous lines for representing the crest. Okay, don't confuse. Okay, don't confuse. Okay, this is a simplified presentations. Okay, in almost all applications we are going to use this kind of simplified representation to represent the assemblies of nut and bolts and all these things. Okay, So keep in mind these things. Okay, don't get confused. Okay, so here in these things, the whatever the thicker line is there. Okay, so you can see over here. So this one will be representing with the thick whatever I am showing over here. Okay, so this is of outside crust is there for external thread. Okay, so next within inside we are having these lines. So these are all the portions where we are having these roots. Okay, you can understand over here completely. Okay, so thick continuous line for the crest and thin continuous line thin continuous line corresponds to or representing to the root of a thread. Okay, you can see this also. Okay, so center line is axis of the thread. Okay, so it will be showing over here. The crest is there, the pitch is there on the both the side, pitch by 2. So this is the runout, thread runout, the end portion of the threads. Okay, sectional views, it is been showing. Okay, so ISO metric thread. Okay, International Organization for Standardization, ISO metric thread. Okay, external thread, and it is internal thread. Okay, center of the thread assemblies. So it is P by 4. So this distance is P by 4 over here, and this distance is P by, sorry, here it is P by 8 and here it is P by 4. Okay, P means pitch. Okay, thread angle, it is being shown as a 60 degrees there. Thread assembly occurs if and only if the both internal and external threads have an equal nominal size. Okay, equal nominal size. Okay, nominal diameter and a pitch. Okay, if the both are having same pitch and same nominal diameter, then only they are going to assemble, otherwise they are not going to assemble. It's very important. Okay, so this table shows the nominal diameter metric coarse threads. Okay, so this one. Okay, so here M6, you'll be, when you go to the shop, you'll be yeah, calling the names of, give me M6 thread. Okay, thread of M6, M8, M10. Okay, what is this M10, M6, all these things. Okay, so here comes the picture. Okay, so 6 refers for the major thread diameter, major diameter, and pitch is of 1. Okay, so here it is a minor diameter is 4.92, and we are going to use the tab drill size of 5 mm. Okay, getting this one. Okay, so similarly M8. Okay, so M8 means the diameter is 8 mm. Okay, major diameter is 8 mm, and the pitch is about 1.25, and minor diameter is of 6.65. Okay, then we are going to use the tab drill size of 6.75. Okay, so M for metric thread, and 12 here it is there representing with the diameter. Okay, okay. So minor diameter is equals to, almost all equals to what? It is a tab drill size. Okay. In thread drawings, the following relationship is used. Okay, so minor diameter. So minor diameter, how can be taken up? Okay, the minor diameter is equals to the major diameter minus pitch. Okay, so if you take an example, uh, the minor diameter, okay, here it is the minor diameter, say around 5. Okay, so what it is given for this, the major diameter is equals to 6. Okay, minus pitch is given a 1. Okay, so 1, so there is equals to what, this is equals to 5. Okay, so like this. So metric for fine thread, okay, M8. Okay, again there is a fine threads. Okay, so this is a major diameter M8, and we are having a two types. Okay, 0.75 pitch and 1 mm pitch. Okay, over here. So then it becomes a 7.188 will be the minor diameter for this pitch, and for this pitch 6.917. Okay, it's almost all we are going to use this tab drill size. Minor diameter is equals to always the tab drill size. Okay, so same here, over here, the minor diameter is equals to major diameter minus pitch. Okay. Drawing steps of external thread. Okay, very important for drawing the assemblies of nut, bolts and washers. Okay, first you draw the axis, thread axis. Okay, very first mention the major diameter. What is the major diameter of 8 mm? Okay, 8 mm is there, means 4 mm on either side, 4 mm on either side. Okay, starting positions. Okay, thread length. What is the thread length is there? So minor diameter you have to specify. Draw 45 angle degree chamfering on both the sides. Okay, so you follow these steps very clearly so that you can helpful for the drawing the assemblies. Okay, draw line making with 30 degree with the thread axis. Okay, thread axis and all these things. So join these lines, these are the highlighted ones. Center axis. Draw a circle. Okay, draw a circle. You can see here. Draw a circle